reach to 200, only reach to 400 kilometers or so. Similarly, soft X-rays, hard X-rays can penetrate a little more, but they also don't reach to the ground. So in order to observe in ultraviolet or X-ray X-ray bands, we need to send our telescopes in space. So that is where the space missions or space observatories come into picture. And when we are talking about space observatories, space missions, that becomes extremely challenging because making instruments working working there in space in harsh conditions is extremely difficult, because if they do not work or if there is some fault, you cannot go there and fix it. So it's extremely challenging. Because these are space experiments, they are also very, very expensive also. And therefore there aren't many of them, and there are not many of them. So what is the importance, and what is the importance, and how do the space-based astronomy, which and when we are talking about X-ray, ultraviolet astronomy or X-ray space astronomy, we are talking about high energy space based, because the energy of this radiation is high. The particles which emit these radiations, their energy is also high. So we call them this branch of astrophysics as high energy astrophysics. So this, of course, is done with the space observatories. So in the modern time, these space observatories are very, very important. Okay, so the construction of a large space observatory, such as the Astrosat mission, its operation and scientific advancement, is kind of a marvel of modern science, technology, brilliance, and creativity. This, some of you may, when you get interest in physics and astrophysics or engineering, you may or probably will be joining such space missions as part of ISRO or some other research institutes in India as well as abroad. So the effective operation of such large space observatory like Astrosat leads to major scientific advancement. I say in time to time, you may be reading in some of the newspapers, okay, India's Astrosat mission has discovered this, or even Chandrayaan mission or other space mission discovered this or find this and that. This kind of news you must be assuming, because this is an effort of a large number of people, technicians, engineers, and scientists. All of a large number of these people are devoting and making their effort in realizing these space observatories, operating, constructing, operation, and finally scientists using these facilities to doing their research and advancing our knowledge of the space. So this is very, very challenging and very, very satisfying career as well. So in that context, because multi-wavelength astronomy is very, very difficult, so India's ISRO came up with this mission called Astrosat, and it is a multi-wavelength space mission. It is sensitive in the optical, near ultraviolet, far ultraviolet, soft X-rays, hard X-rays, even low energy gamma rays. So it has different instruments. So for example, it has one UV telescope. The name is Ultraviolet Imaging Telescope, or we call it UVIT. There are these twin telescopes, and this produces fantastic images. I'll show a few of them. This produces fantastic images. Then we have X-ray instrument. One of them is called the soft X-ray telescope. It can take image in X-rays. It can measure spectrum. It can also measure how X-rays are actually varying with time. We have another telescope we call is LUX-PC. This is a large area X-ray proportional counter. It's one kind of a X-ray telescope or detector. This telescope's importance of this particular instrument or payload has a fantastic capability for measuring variability, how the X-ray flux is changing with the time. It can measure variability on very, very short time scales, on something like 10 microsecond or so. So people have studied we have been studying very, very fast variability in cosmic X-ray sources and down to something like on millisecond scale or so. Yet another instrument is this CJTI, which we call cadmium zinc telluride imager. It is a hard X-ray instrument. It can image hard X-rays or high energy X-rays. And it can also do the variability study or take the spectrum, and it has other capabilities which I'll not go into the details. So this Astrosat mission, our space observatory, was launched on September 28, 2015. It's very soon. It is going to complete 9 years in operation. It has been working very successfully. It has actually resulted more than 400 scientific publications in international research journals. That's a big achievement for India on various, and that's the importance of. I mean, that is what is coming from a suite of different instrument with the capability of multi-wavelength observation in a single satellite or space observatory. And this, of course, is an effort by a large number of people from a number of institutes in India as well as abroad in University of Leicester and the Canadian Space Agency. So you see this instrument LEXPC was contributed by the Tata Institute of Fundamental Research and Raman Research Institute. TIFR is in Mumbai and the Raman Research Institute in Bangalore. Soft X-ray telescope contributed by TIFR, ISRO, and the University of Leicester. The CJTI instrument was contributed by TIFR, ISRO, and IUCA, my institute essentially. SSM, there is another scanning sky monitor. This is another instrument in Astrosat that is by ISRO, IUCA, RRI. Then UVIT, the UV telescope is built by IIA, ISRO, IUCA, and the Canadian Space Agency. The spacecraft and operations are essentially the major effort. The effort was done by ISRO, and the operations are still being done successfully. Then the various other institutes. So for the science support, we have a science support cell at IUCA, Associate Science Support Cell at IUCA, which was again established by ISRO and IUCA, where we support scientists all over India as well as abroad in getting the data, analyzing data, doing science, etc. So there are training workshops for research students and research scientists as well. So where is this satellite? As I mentioned, this was launched on September 20th, 2015. We were there during the launch. It is such an amazing experience to view this launch while there at Sriharikota. The satellite orbits in a circular orbit, and it is at a 650 kilometer above the sea level. Okay. So, and as I was mentioning, it has a multi-wavelength capability. For example, the UVIT is sensitive in the visible band, in the ultraviolet band, far and near ultraviolet bands. Then the soft X-ray telescope is sensitive in the soft X-ray band. Large area X-ray proportional counter is sensitive. It's a high energy band. Both CZTI and LXPC, these are sensitive in the high energy X-ray band. And that is how the Astrosat instrument or Astrosat telescopes cover from optical to all the way to high energy X-rays. So how do people research? How do people use such facilities and do research, or how the scientific progress happens using this kind of space mission? So generally, the scientists have some scientific problem. We do not understand something about a star or a neutron star or a supernova explosion or a black hole, etc. And then once they have this scientific problem, they think of what kind of observations can help us understanding this phenomena or this problem. So then, given that, they look at, okay, what are the opportunities available? What are the space missions available? And they write their scientific problem in terms of a proposal, and they show through the computer simulations, etc. So demonstrating that if you observe this particular cosmic source with this particular space mission like Astrosat, we will get the data that we will analyze, model that data, and finally solve the problem. This is how generally happens. So Astrosat also is operated like this. So the scientific community from in India as well as from abroad, they submit these proposals, and these proposals are reviewed by an expert committee. And some of them are actually accepted for observations, and those proposals essentially determine the mission planning, scheduling, and observation. When the observation is done, the scientific data is downloaded from the satellite, and this data is then given to the scientists. These scientists then analyze this data using physics, and they try to understand based on such data, and that's how scientific advancement happens in observational astrophysics or space-based astrophysics. Okay, so with this multi-wavelength satellite, what are we using for? Okay, so some of these objects are they actually emit in very different bands. I already mentioned the supernova explosion, I mean the supernova remnant, or the Crab nebula. There are other kinds of objects which are very, very useful. One class of them are called active galaxies. So first of all, what are galaxies? The galaxies are essentially piles of stars. We are piles of stars which are gravitationally bound. You may have heard about Milky Way galaxy, which is our own galaxy. Our star, our sun, our solar system is located is part of this galaxy. There are billions of other galaxies. Some of these galaxies are called active galaxies. So what happens is the center or the nucleus of this galaxies is very, very bright. For example, here you see one image of an active galaxy called NGC 4593. This is a spiral galaxy because you see this beautiful spiral structures. But at the center, there is a very bright star-like object, pint-like object. And that very bright object is due to some kind of activity. And that is why these are called active galaxies. And we think this activity is due to the presence of a black hole, which is a very, very massive, a million to billion times the mass of the sun. And such a black hole, when it is there at the center, it will attract material surrounding it, and the material moves closer to the black hole. And this process, we call it accretion process, and that generates huge amount of energy, and that is observed in the form of radiation. There are similar objects, I mean, not similar, but process is similar, but they are in our galaxy called X-ray binaries. These are binary objects, meaning these are systems of two objects. One of them is a normal star, like our sun, for example. The other one is a compact object, like a neutron star, which I mentioned earlier, or a black hole, for example. When such a thing is there, because neutron star or black hole are very, very compact, their gravity is strong, so they pull the material from the companion star, from their binary counterpart, binary friend. And they accrete material, which means the material moves towards the compact object. And this process generates a huge amount of energy. And again, they are strong emitters in the X-ray band, as well as in the ultraviolet band. And these objects are highly dynamic in nature, meaning this process of accretion that varies a lot. So the radiation in ultraviolet, soft X-rays, hard X-rays, gamma rays, etc., that is also highly variable. So in order to understand these objects, we need to observe simultaneously in ultraviolet, X-rays, gamma rays, etc., and look into how things are changing, etc. This information, and that becomes very useful. And that is what Associate is doing. Associate has done quite a lot of this kind of study and is still doing. And Associate, the multi-valent capability, of course, useful in other aspects, but this major science aspect is this. And I think. I will stop here. Because I do not want to go to too much technical details about scientific output, etc. And if you have questions, etc., we can I can answer now. Thank you very much for listening this talk.
Thank you very much, sir. Thank you very much. आई थिंक सर ने अभी जो एक लेक्चर दिया जो एस्ट्रो बेस जो ऑब्जर्वेटरी है उसके बारे में हम लोगों की जो समझने के लिए है उसमें से दो तीन महत्वपूर्ण बातें हैं कि जब सर ने एक फेमस फेबल की चर्चा की कि एक हाथी को यदि अंधा आदमी यदि हाथी को अलग अलग पार्ट को देखे यानी बड़ी समस्या को देखे तो वो अलग अलग चीजों को वो समझता है। तो जरूरी इस बात का है कि हर चीजों को समझने के लिए जरूरी नहीं है कि हमेशा हम उसको आंख से देख ही सकें। कई किस्म से इंफॉर्मेशन हमारे पास आती है, उस इंफॉर्मेशन को हमें बेसिक हमें उसको समझना पड़ता है। और साइंस में खासकर जो स्पेस का जो साइंस है उसमें ऐसे ही टेक्निक्स पर ऐसे ही टेक्नोलॉजी पर हम डिपेंड करते हैं। और जो दूसरी महत्वपूर्ण बात सर ने कही कि हम टीम वर्क में काम करते हैं। सिर्फ इतना बड़ा जो प्रोजेक्ट चलता है इसमें सिर्फ साइंटिस्ट नहीं होते, इंजीनियर, साइंटिस्ट, टेक्नीशियंस सभी लोग इन्वॉल्व होते हैं और तभी इतना बड़ा काम हम कर पाते हैं। यानी साइंस में हम सभी के लिए ये जानने और समझने की जरूरत है कि टीम वर्क जो है वो बहुत महत्वपूर्ण है, तभी हम अच्छा एडवांस साइंस हम कर पाएंगे। मैं चाहूंगा कि आप लोगों से कोई यदि सवाल हो तो जरूर आप सर से पूछ सकते। कोई एक सवाल, कोई एक सवाल। यस यस।
सर आप किस चीज पर रिसर्च करते हैं?
मैं मल्टी वेवलेंथ एस्ट्रोफिजिक्स और एक्टिव गैलेक्टिक न्यूक्लियाई और एक्सरे बाइनरीज जो कि मल्टी वेवलेंथ रेडिएशंस इमिट करते हैं। और मैं उन चीज़ों को एस्ट्रोसेट ऑब्जर्वेटरी से ऑब्जर्व करता हूँ और वहाँ से जो डेटा आते हैं उसको एनालिसिस मॉडलिंग करता हूँ। इसके अलावा जो इंटरनेशनल नासा के मिशन हैं या यूरोपियन स्पेस एजेंसी के मिशन हैं उनको भी यूज करके हम ये एस्ट्रोफिजिक्स पर्टिकुलरली एक्सरे एस्ट्रोफिजिक्स और अल्ट्रावायलेट एस्ट्रोफिजिक्स मैं करता हूँ। और इसेंशियली मेरा रिसर्च का पर्पज ये है कि जो सुपर मैसिव ब्लैक होल्स हैं, जो मिलियन टू बिलियन टाइम्स ब्लैक होल्स हैं जो कि गैलेक्सीज के सेंटर में होता है, उनके आसपास क्या हो रहा है वो उसको ऑब्जर्व करते हैं हम एक्सरे रेडिएशन थ्रू, और उसको एनालिसिस करके उसके आसपास क्या हो रहा है ब्लैक होल के आसपास वो पता करने की कोशिश करते हैं।
थैंक यू सर। एनीवन एल्स? यस, यू वांटेड टू से? किसी और को सवाल पूछना है? एनी क्वेश्चन फ्रॉम यूट्यूब? एनी क्वेश्चन? यूट्यूब से कोई है? So yes, there are few questions from YouTube also.
Sure.
Okay, sir. So we'll stop it here, sir. Thank you very much, sir.
Thank you. Thank you.
You at a very short notice, you agreed to give this lecture to our students. We are grateful to you, sir. Thank you very much, sir.
Thank you. Thank you very much.
I would like to thank our students from Kendriya Vidyalaya. They are from the junior sections of Kendriya Vidyalaya, NCERT to Delhi. Thank you, sir.
Thank you.
थैंक यू भाई।